A particle can move on the smooth outer surface of a sphere of radius r. If the particle is released from rest at on the smooth surface of the sphere at a height of 4r over 5 above the diameter, above the horizontal plane through center of the sphere, find in terms of r the height above the plane at which the particle leaves this sphere. Okay. So, yeah, okay. So we have to find the particle can move on smooth outer surface of fixed radius r. The particle is released from rest on the smooth surface of the sphere at a height 4r over 5 above the horizontal plane through center O. Find in terms of r the height above the plane at which the particle leaves this sphere. Alright, that makes sense, okay? So what's going to happen is, eventually it's going to move out here. Now currently it's being supported by the reaction force between any particle and its surface. At the moment it leaves the plane, r equals 0. It's the first thing you got to remember. If we draw just the circle again down here, first thing we're going to do is we're going to figure out what exactly is this height that it starts off at. Okay, we're going to figure out information about where it starts off. Okay, so it's up here at the start on the outside of the rectangle, so we're going to make a triangle. So the triangle looks like this. Now, and this is the plane here. Okay, what we know is this is 4 over 5r. We know that this here is the radius, and let's call this theta. Once again, it doesn't matter if you label this angle here, it really doesn't matter. All you're doing is changing signs of causes, same formula applies, okay? So we're just going to do this one down here. Now, what we can say right away is that sine theta is 4 over 5r divided by r, and that will give us 4 over 5. Automatically means cos theta is 3 over 5, and it means tan theta is 4 over 3. Now you'll also do Pythagoras' theorem to figure out what x is, so you'll get r squared equals x squared plus 4 over 5 r squared. You'll square that out, you'll get r squared equals x squared plus r squared equals x squared plus 16 over 25 r squared. Bring the 16 over 25 r squared over to your side, you're going to get 9. You're going to get 9 over 25 r squared equals x squared, and then x is equal to 3r over 5. Okay? So that will give us our 3r over 5 located here, or 3 over 5r. Now that we've done that, there's always two formulas for this type of question when you're rotating around what's called vertical circular motion. There's two equations. The first equation is the conservation of energy. And equation 2, which we're not going to be using just yet, is going to be centripetal acceleration. And it's always these two for this type of question. Okay? Energy means that energy at start equals energy at end. So total energy at start is mgh1. This is your potential energy at the start, plus your kinetic energy at the start, which we'll call a half mv1 squared, and it has to equal your potential energy at the end, which is mgh2, and your speed at the end, or your kinetic energy at the end, which is mv2 squared. Okay, and this is kinetic energy at the end. So here's your formula. Now let's see what we can fill out. M is here, and then gr. Okay, so it's going to be G is here, and then H1. What's H1? 4r over 5. Quick note: if I was to redo the full thing from down here, and add on an extra r, it would still work out the same way. So for example, it would no longer be 4 over 5r, it would be 9 over 5r. It actually still works out the same because you're adding the same amount to both sides. Okay? So it doesn't matter where your reference point on the plane, you choose whichever one makes it easier. The one thing you can be dead sure of is that the particle has to fall off before it can't go down here. It has to fall off above the diameter plane. You got that? So that's why in this particular question you get away with doing that. Okay? So what we're going to do next is h is going to be 4 over 5r. There is no movement at the start, which means you have no movement here. Okay? Then your particle ends up here. This is height h2 above the ground, and it's travelling at v2. Okay? So when you reach here, the point at which capital R equals 0, what you're going to be doing is you have v2, and now it's h2 above the ground, h2 above the diameter plane. Okay? So what we have next is mgh2, because we don't know anything about it, and then we have a half. Now let's call v2 v, just get rid of the 2, okay, because there's no other v's going. Okay, that's our first equation here.
All the m's cancel.
And all the m's will cancel. I'm going to leave it, and you'll see why in a second, if that's okay with you. Okay, I'm going to leave that mv squared where it is, and I'll show you why in a second. Okay, so next thing we're on is centripetal acceleration. There is no sign of omega in this question. There's no sign about like anything to do with omega. Okay, it doesn't say find angular speed. It doesn't say, so that means that I'm just going to use the regular formula, mv squared over r. Now, for the centripetal acceleration or force, F equals mv squared over r. What happens next is we got to find out what F is. Okay. Now please remember that this acceleration is going directly into the center of the circle that you're covering. Okay. So let's go back to the top and figure out what are our forces at play here. Okay. Well, we're going to have a reaction force R that's always perpendicular to the surface point and diagonal right out. What we're going to have, we also have the mass of the particle, which is mg. See the mg? Yeah. Now, this mg, I'm going to draw it in the corner, is acting directly down. I need to resolve it into two components. I want to resolve it as a tangent to the circle and parallel to the radius. So I need to resolve it like this. Now, because I'm resolving it like that, follow your theta. Okay, that's 90. That's 90 minus theta, which in turn makes this angle here theta. So this angle here is theta, which means that this angle here is mg cos theta going down, and mg sin theta going into the circle. Okay? So mg sin theta going directly into the circle. Now, there is one problem, okay? That's for the start, isn't it? I didn't actually do it for its current position. Theta is the starting position. So look at this, guys, okay? Let's get rid of all this for a second. Okay. Now, what I'm going to do, this was your starting off position. This is your end position. And what we need to do is we're going to do a different colour here. Okay, perfect. So this is your current position. This is your current centripetal acceleration. It's not at the start I had 0 centripetal acceleration because it wasn't moving. So we're talking about the current situation just as it's leaving, okay? So what we're going to do here is we're going to call this angle alpha. We're going to do the same rule as last time. We're going to resolve it horizontal and perpendicular. So basically, all I'm doing is see my thetas, just change them to alphas. It obeys the exact same rules. So it's mg cos alpha, mg sin alpha, and that's alpha there. So I'm basically talking about resolving it parallel and perpendicular to the radius at that point in time. Okay? So what's going to happen is it's mg sine theta aiming directly into the centre of the circle. Okay? So this means centripetal acceleration is mg sine alpha, which is going directly in. Please remember it's being opposed by a force R, which is going this way here. Okay? The weight is acting inwards, but R is acting outwards. And then that in turn will equal mv squared over R. Okay? Now, we're going to change the sign. We don't know what sine alpha is just yet, but we do know that R equals 0. And we're going to cross multiply the R, and we're going to get mgr sine alpha. Now that's why I didn't cross off the m's. Okay? So we can see the comparison between equation 1 and equation 2. We can see that this here has your nv squared. So I suppose what we could do is multiply both sides by 2. Okay? So this is going to be, this is meant to be 4 mgr over 5. I'm going to multiply that by 2. I'm going to get 8 mgr over 5. I'm going to get 2 mgh2. And then I'm going to get mv squared. Okay? I'm now going to change this mv squared into mgr sine alpha. Mgr sine alpha. Okay. Now, what is mgr sine alpha is mv squared. Okay. Now, is there a way out of this at the moment? We currently have 2 variables. Sorry, guys. Oh, the problem at the moment is, if you look at this equation in red, we currently have 2 variables. We have the variable alpha and we have the variable h2. One of them has to go. We have to figure out which one to get rid of. I'm going to look at h2 in more detail and see if I can get rid of it. Now look at this. h2, if I just get rid of all this here, this is h2. Look, h2 is the red line going directly downwards. Okay? This is R. Sine alpha equals h2 over R. h2 equals R sine alpha. That now gets rid of h2 and puts it in terms of the other variable in the equation. Okay? So what we're going to get is that's 8 mgr over 5. And this equals I will do in a second. What's h2 again? R sine alpha plus mgr sin alpha. Now somebody told me to get rid of the mg's. Okay, 8r over 5 will equal 3 sin alpha, and therefore 3r sin alpha. Well, the r's will also cancel, won't they? Yeah. So what's sin alpha then? Sin alpha is 8 over 15. Okay? Now, this 8 over 15, okay? This 8 over 15, okay, so we had a formula earlier on that said mv squared equals mgr sine alpha. Okay, cancel the m's, and what we get is phi squared equals gr sin alpha, which is 8 over 15, and finally phi squared. Phi squared, we're going to change that g to so phi squared equals 8 over 15 gr. Okay, now the whole point of the equation was to find the height h2, wasn't it?
Yeah, we got it.
Oh, did we?
Yeah, so it's 100/1.
Yeah. Oh, sorry, h2 equals r sine alpha, so I already got it, sorry. 8 over 15 r. Grand, we got the secondary height, okay? Moving on to the next question, 6b. Okay. A particle moves in a straight line such that its displacement from a fixed point O at a time t is given by x equals a cos wt minus b, where a, w and b are positive constants. Show that the motion of the particle is simple harmonic motion. Okay guys, the rule for simple harmonic motion is this. The acceleration is in opposite direction to the displacement. Acceleration is directly proportional to the displacement and is in the opposite direction. So what we need to do here is differentiation. Now, that's the formula. We are differentiating with the variable t because amplitude is a constant and omega is a constant for the particular simple harmonic motion you're in. The only variable there is t. Let's differentiate dx dt. Now, what you know automatically is the constant stays the same. Cos theta turns into minus sine. Oh, sorry, I forgot the minus b. The angle, when you differentiate, never changes. And what you do have to do at the end is you got to differentiate the angle. Now, when you differentiate wt with respect to t, what's the answer? It's whatever number comes in front of the t or letter, which is w. Okay? So dx dt therefore turns out to be minus aw sine wt minus b. Differentiate again. So velocity is the first derivative, change in distance over change in time. Acceleration is the second derivative, okay, which is change in velocity over change in time, or the second derivative written like that. So what we get next is, once again, the minus aw is safe because it comes in front of the derivative. You then change sine into cos. The angle never changes. And then finally, at the end, you got to differentiate the angle with respect to t. That gives you w. And what you're going to get here is minus a w squared cos wt minus b. Now, compare that to your initial equation, x. We have the a, we have the cos, and we have the wt minus b. So, in result, a equals minus omega squared x. This obeys simple harmonic motion because the acceleration is directly proportional to the displacement, and because of the minus sign it's in the opposite direction. Okay? While we're here. So, therefore this undergoes simple harmonic motion, so you go dot 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 SHM. Therefore it obeys simple harmonic motion. Okay, 2004 B part 2. Find A, W and B. Find A, omega and B. Now, we're given information. The period of the motion is 16 seconds. At a time t equals 4 seconds, the particle is distance 12 from O. And 4 seconds later, the particle is on the other side of O at a distance 5 meters from O. Find A, W and B. Okay, so our formula is, the previous question is now doesn't really matter. Okay, and what we're going to be doing is just using our formula here. Okay, so part 1. Okay, draw your diagram. obviously prefer that in black. Okay, here you go. O is dead center. It says that in the question, doesn't it? That O is the obviously the middle. Oh, sorry. O, other side of O. Period. Does it say in the description? From a fixed point O. O is the center of the motion. Okay. Next thing. What happens is 12 meters at t equals 4. Okay. It ends up on the other side. 5 meters away, which is a lot closer than 12 meters away, at t equals 8. Okay, so what happens is, we don't know if the 12 is the full amplitude or not, do we? There's no guarantee. So it might do something like this. It'll go all the way up here, t equals 4, we'll pass it out, it'll stop at some random point out here, then its velocity is 0, then it gets accelerated all the way back into here, stops here, oh sorry, it doesn't stop here, it goes through here at its full velocity, then we'll go through to this point here, and it will be decelerating as it gets to T8, t equals 8. Okay, so basically like this, over, back, slowing down. Okay, so we got to figure out what we're doing here. Okay, now the formula is x equals a wt minus b, which is perfect. Okay, now the period of our motion is 2 pi over omega. Okay, and it says, what does it say? Period of motion is 16 seconds. Okay, if it's 16 seconds, this means 2 pi. 2 pi equals 16. So we want to get a omega on its own. So 2 pi over 16 equals omega. Omega equals pi over 8. So look, we figured out what W is straight off the bat, right, which is good. Now we can redesign this equation so that it's now x equals a cos pi over 8t minus b. Okay, and now we've got to start putting in some values. Okay, let's put in the first value, 12. The displacement from center equals a cos pi over 8 t minus b. How many variables do I have in this equation? 2, don't I? Now, this displacement here, it's not 5, it's going to be minus 5, because it's to the left. Minus 5 equals a cos. Now, I forgot to put in something there, didn't I? I forgot to put in the time. T equals 4. So I can put a 4 in here. Okay. And then this one here is t equals 8. So 8 times pi over 8. Just pi, isn't it? And this one here is going to be pi over 2. Now guys, look at these two formulas. Now what's the problem still at the moment? Sorry? Oh sorry, still 2 variables, okay? Yeah, so it's pi over 2 below, okay? So still 2 variables. Now there's 2 ways of doing 2 variables. Simultaneous equation is one, isn't it? Now why isn't a simultaneous equation currently not on? Well, they're not, the variables aren't separated from each other, are they? Is there a way of doing that though? A way of separating out angles from each other? Okay, so there is. It's what's called cos A minus B. Cos A minus B is cos A cos B minus sin A sin B. Let's expand both equations. The reason, that's a hard one to find in the test, but they're both stuck in the angle position, which means that we need to separate them out. So what we're going to get here is this. Now remember, the A is still very much on the outside, okay? So what we're going to get here is 12 equals A bracket, now cos A, cos pi over 2 cos b. Now what's cos pi over 2, lads? Cos pi over 2 is cos 90, which is 0. Get rid of it. Don't need it. Minus sine pi over 2 sine b. Okay, stop there. The other one, which is minus 5, equals a times cos a cos b, which is cos pi cos b. And can anybody tell me what is sine pi? 0. So that's minus 0 this side, so we can get rid of that as well. Now, currently we have two equations which are in blue, one above the other. We still have how many variables? We have beta and alpha. Any suggestions how to get rid of the alpha? Divide the two equations is right, Dan. Divide them, okay? And what we're going to get is 12 over minus 5 equals... Now, what is sine pi over 2 again? 1. What's this one here? Cos 180? Minus 1. Okay? So what we're going to get is minus sine b over cos b, is it? Yeah? Yeah.
Cos A minus B is cos A cos B plus that.
Oh, sorry, it is plus, excuse me. So they're both pluses, okay? That affects this one here, right? Because that was meant to be a plus sine A sine B. So guys, excuse me, right? Now there's one other reason why you might know that as well. It just gives the angles too big. It'd be a negative angle, okay? So sorry, that was a plus, and this one here is a minus, okay? So what happens next is they cancel out. So the minuses cancel each other, and what we get is tan b equals 12 over 5. If tan b is 12 over 5, what does that mean about cos b? It's going to be a right angled triangle with hypotenuse 13. Yes, Ben? Yeah, what happened was the formula was meant to be a plus here.
Yeah.
And I put in a minus by mistake. So I changed the minus by mistake to a plus because it's the only part that got affected. Okay? So then what happens next is we now know that cos b is 5 over 13 and sine b is 12 over 13. Okay? So we found out what b is. We haven't found what b is on its own, so we have to obviously we have to inverse it. Okay? So what's tan inverse 12 over 5, anybody? In terms of radians? Sorry? 1.176 in terms of radians. That's what b equals. Now the only thing left to find is what? The amplitude, isn't it? And we know that 12 equals a sine b, doesn't it? So 12 equals a sine b. Therefore, a equals 12 over sine b, and sine b is 12 over 13. So it's 12 divided by 12 over 13. This makes the amplitude 13. Okay. Well done, guys.